Can you build your own SaaS AI product in just 5 days? The answer is yes. In the next 5 videos, we'll walk through every step together using no-code tools to create a complete AI SaaS product with a user-friendly interface and OpenAI integration. Subscribe now so you don't miss a single lesson. Hey everyone, I'm Mark and welcome to my channel where we build the future together using no-code and AI. Today we're going to talk about AI chatbots for Telegram with OpenAI. The standard assistant nodes in platforms like N8N are great, but they do have some limits. You can't easily change instructions on the go, and using thread IDs for memory isn't simple. While recent updates have added some memory features, it's still really useful to know how to work directly with the OpenAI API so you aren't limited by the features N8N offers. In this video, I'll show you how to build 3 simple chatbots, some with memory, some without, using Telegram, OpenAI, and Supabase. This is the first step in learning how to create your own AI SaaS products with no-code tools. Let's get started. Let's create a simple AI bot with Telegram, memory, and OpenAI integration. Based on OpenAI, first we need to open N8N. If you haven't created this yet, you need to deploy your self-hosted version or connect to a plan and add the credential. We add the API token. Once it is added, there will be a message saying, "Connected action tests with accessibility." This means that everything is fine and the connection has already been tested. It's better to insert the correct naming right away and save it immediately. We will also need to include credentials for OpenAI. Additionally, we create a key and copy it here. We will also need Supabase. We copy access to the service keys. Done. Now we are indeed ready to start the actual development. I have already created a new script, and we will start by gradually examining the options for creating simple bots, how they work, and slowly work our way up to the point of working with assistants and more complex bots. To start, we will have a simple script where we take a message from Telegram. Then we send it to OpenAI, process it there, and send the response back to Telegram. Now let us commence with a regular Telegram webhook. In general, all interactions consist of either webhook or HTTP requests. A webhook is a server that will wait for new events. That is, when we send a message to the Telegram bot, Telegram will send us information about that message here. Let's test it. We selected the necessary connection, activated it, went to the bot function, and pressed the start button. So we sent a message to the bot and received it. Here we can go to execution and select the desired execution, and by clicking on the node, we can see what data we received. Here we mainly receive additional data about which chat the message came from and who sent this message. Here, the user ID, their name, username, and the date when this was received are specified. There is also the text of the actual message. Next, we need to process this message. For this, we will select the OpenAI module and the simple message module. We connect it to the Telegram node. Here, we choose the credential that we created earlier. Next, we select the model. Let's choose 4o Mini. It is the cheapest option right now. And we have a simple output. For now, we won't change anything here. Let's pin the message. Let's return again. To execution, we'll go into JSON. Here you see pure JSON. You can copy it, return to the desired module, and click here on the pencil icon to edit the JSON. In this way, we fix the output and can use it as an example in further modules. Here, we will choose the text. One needs to be careful, because by default, when you transfer or map data, JSON is used here. In other words, it essentially points to the previous module. If you swap the modules or add something, it may get messed up. Therefore, it is best to specify the full path, and this should be removed in general. We can delete everything. Put a $sign. Select the previous nodes. Next, we click the dot. We go down one level. This is the item. In other words, it returned a specific item. Then we click the JSON dot again, so we get access to the information from this item in JSON format, and then we click the dot again, and we dive into the message at this level. Yes, that is, in the message, we are interested in the chat, or rather, no, we are interested in the text. Then we click the dot, and the text is essentially the same as if we had done it this way. Here is the message text, only instead of that, we specified a direct path home. Let's change the text that we supposedly sent to something simple, like saving. And here we are also testing. Here it will send. We are waiting for a response, and we receive the response. We will also pin it right away so that it can be used further. It replied, "Hello, I am a program, feelings, and so on. How can I help?" Next, we need to send this message back to the Telegram chat from where it came. We open the Telegram module again and find Send Message here. Again, we select the required credential. Here we need to map the chat ID. Again, the chat ID refers to which chat we are sending to. It is best to use the chat. If you have a group chat where the bot also resides, you need to be careful because, in this case, it doesn't matter from whom, meaning mapping the data from whom, or the chat. It is still the bot communicating directly with the person. But if he lives in a group chat, then the people here will be different each time. They will write, but the chat will remain the same, so it is best to always use the ID. Next, we need to write the text. We take it from here, from the content, but again, we will replace it here just in case. We will write the full path, but this is not actually necessary. We will send this text to the chat. Next, we will click Test. When our modules are fixed, they are not processed again, meaning we will not ask OpenAI about anything a second time. We already have the information secured. While we are in test mode, when we click Test, it uses the existing data. So we will just send this text that already exists. We will receive, again, some data about who it was sent to, from whom, and so on. We can go back to Telegram and take a look. Yes, you see, we received a message. There is a small note here. We can remove it using a special setting called Painting with a Mantribution. Here we remove it, and that's it. It won't write like that anymore. We save it and test it once more. How can it help us today? He says that he cannot answer what the weather is like in New York right now because he does not provide data in real time. He responds quickly enough. Overall, everything is good. This concludes our very simple bot. Let's move on to the next version, where we will complicate the task. The downsides of this bot, which is why we will complicate the task, are that it does not actually remember our dialogue. In other words, we see this dialogue, but it does not see this dialogue. We simply send messages, and it responds to them. This is handled by the chat completion module in OpenAI. In order for it to remember what we are talking about, we need to create a separate chat with it. This is called thread, and assistants work with a thread. For the next scenario, we will need to create an assistant, change the logic so that the model remembers what we are talking about, and can maintain a long-term dialogue. Let's move on to the next part and consider how we can create chatbots that will remember what we are talking about. We introduce dialogue as well as working with the assistant. For this, let's consider a bit of theory from OpenAI. We'll take a look at their API and what assistants consist of. Here you can see the basic logic of how assistants work. Assistants exist separately. You can create different assistants. They look like this. For example, here you can easily specify the assistant's name, its instructions, select the appropriate model, and efficiently select additional functions that it can use for processing your messages. You should also choose the format in which it will respond, either text or JSON schemas. Essentially, if you are familiar with GPT chat, this is essentially creating your own custom GPT chat that can only communicate via API. To interact with the assistant, you need to create a thread in which your messages and the assistant's messages will be stored. Essentially, when you communicate with the GPT chat, it's all the same. You have created a new dialogue. This is a thread. You write your message, something happens, and you receive a response. You only interact with the basic assistant, which has some system instructions embedded, nothing more. Here we can embed our instructions, To get a response from the assistant, you first need to send a message, and then run the function run, which directly takes a specific assistant, its prompt, goes into a certain thread, and performs some steps. That is, it processes your message and decides to respond with text, perform some function, or do something else. Then, it creates a message from which you can read it. You can run different assistants in the same thread. The assistants can see the history in the thread, but there is probably some limit to this. I can't say for sure how big it is, but they definitely know it. It's not the same as communicating through chat completion, where you just get an answer to your question. Let's create a simple assistant. We'll not set anything special. We will choose the mini model since it is very cheap. That's basically all. We only need the assistant ID and that's it. It will also be useful to study the OpenAI API. You can create assistants via the API, request information from them, and modify them. It also involves creating threads, sending messages there, launching assistants directly in the threads, and working with the storage vector. How does this look in practice? There are OpenAI modules. Their number is limited. They are not keeping up with the updates from OpenAI, so using them is not very convenient, and their functionality is quite limited. There are also agents here. Agents have a few more functions, but again, many of them are already outdated. They lack the features that OpenAI adds every few weeks. Therefore, I see no point in using them. I use simple HTTP requests. Our logic will look like this. We receive a message from Telegram. Next, in order to take this step regarding the message process, we will have to complete a total of 4 steps. We are creating a separate thread. We send a message in this thread. Then we launch the assistant. He processes this message. Then we take all the messages in the chat and send the latest ones to Telegram. I have already pre-created several HTTP requests. Therefore, we will carefully copy what we have and consider what is happening here. To start, we will remove this module. First, let's create a thread. We can go to the API and look at the requests for creating a thread. As you can see, this is a standard request. There are no additional parameters here, just a post and request regarding this label. Here you will need to select the predefined predation type. To use the credentials that we have already created for OpenAI, simply select the desired account. In the hailer, you can add Assistants version 2. Let's create a thread. It was created, and in the response it returns the threaded. Next, we need to send a message to this thread. We open again to create a message. Here, we need to send a post request like this, including the threaded inside it. This is a mandatory parameter. The role is also a mandatory parameter. Usually, it is the user, right? And the content. Our content is regular text, so there are no special quirks here either. You can copy the example from here. Here we are writing according to the thread request. Here we remove it. Here we need to embed the threaded. That's it. Between these brackets, we take it from the previous module and insert it. Again, yes, it's better to remove the previous module right away. Next, we remove all the same parameters for audification. And below, we need to enable sendBuddy. We need to send a JSON like this. It contains 2 parameters, the user's role and content. The content that we want to send, we specify the user's role and the content. This is the content from the first message that we received from Telegram. Ready. We send it. We sent the message, and in the response, we receive that the message has been sent, which message it is, and its ID. Now, in order for the assistant to respond to it, we need to create RAM. RAM essentially involves launching a specific assistant in a specific thread. Again, this is a standard post request in which you need to specify the thread where we will launch the assistant. This is a mandatory parameter. The second required parameter is the assistant ID. That is, the ID of the assistant that we created right here. There are additional parameters. You can change the model. That is, there are default parameters for the assistant that you configure here. But at the moment of launching it in the web chat, you can essentially change all of them. You can change the model. You can change the instructions. You can add some instructions. If you have a specific idea in the system instructions, but then you want to change something specifically for this request, you can add an additional instruction, which I also find useful. You can specify which tools it should use specifically in this RAM, and also change other parameters. An important parameter here is the stream, because if you simply create a run, it will instantly return a response indicating that the run has started. However, we need to wait for the completion of this run. This may take a long time. Yes, the assistant can take a long time to respond, therefore we need to wait for it to finish. For this, we must set stream to true. Then it will return the logs of the entire RAM. That is, in the log of everything he did, he will return, yes, he will say that I created RAM, now I am this assistant, I am processing this message, I processed it, I responded to it, I am ready, here it is. That is, it will return all this information, and after that, we will be able to view the message and take it. Otherwise, we won't be able to see we if we request a message. It won't be available yet. In the previous version, everything was done automatically. That is, we simply send a message, and it responds to it. If it takes a long time to do something, it will take a long time to return the response. Here, however, the response without this parameter will return instantly. We again enter a post request, we enter the URL, and we map the data from ready from the previous module. Yes, you see, if you pull the module not from the nearest one, but from one in between, it will immediately return the full path to the module automatically. Next, we specify the authentication data, the header, and in the body, we write the assistant ID, indicating the ID of our assistant. We set stream to true. Here, I made it in the expression so that it is true, not text. Because in JSON the value is true, yes, if you write it there, and in JSON it can look like this. Next, true will be the text, but we need true to be a Boolean value. For this, it needs to be specified in this form. Then we specify additional instructions, which we don't need here, so we remove them. We also remove true choice. This was just an old mod of mine. Yes, the stream and the system of additional instructions can be launched. Wait, let's check if we saved the previous message. Yes, we pinned it here, so it wouldn't launch again. And now we are launching the assistants. Since we have a simple message, he responded quite quickly with this kind of text. In other words, here, essentially all the information is one huge text log that we will have to break down in order to. In fact, no need to break it down now, but in this case, later you might need this runid. If you are sending multiple messages, let's say in my case, it was when I send one message, launch the assistant, then send another message, launch the assistant again. And only after sending all the messages, and after they have been processed by the assistant, do I launch the module to retrieve the message. In this case, I need to understand which of the messages in the thread are the assistant's responses. Yes, since they can still differ categorically, it might be possible to figure this thing out, but we will discuss it later. Next, he replied to the message. We will also pin this. It is not necessary to do this. There will be more tests. Next, we need to take the message from the thread. Messages, list messages, the request get to take, that is yes, we are not creating anything. It is necessary to specify the thread. This is the only required parameter. We specify the 5th-4th ID mapping from the previous module. We provide all the credentials. There is basically nothing here, but the credentials are still important. We start and we receive such a message. Here are all the messages. That is, it is important to consider that there is a limit on messages. By default, it is 20 messages. If you are managing a lot of messages and processing many of them, and then you want to process them all, you need to remember that it will only output the first 20 by default. You can change a maximum of 100. You can also change the order, for example. The default order has the most recent message at the top, and we need to take, essentially, the very last message that he replied to us. He essentially replied the same thing again. We are moving on to the next module, and here, the only thing left for us to snipe is the chat ID, which we have already sniped. We need to retrieve this message. Let's replace it right away. getMessage.json done. Again, we can test and confirm. We will save it. We have sent this message again. This concludes the review of the bot. But, as you can see, we have learned to create threads, send messages within them, and work with the assistant. But the problem is that if you send another message, we will do everything from scratch. We will recreate the thread, send the message again, and so on. Again, it will not remember previous messages, because each time we are essentially creating a new chat. In order for the chat to be saved, we need to add one more layer. This layer is a database that will store data about the thread we created and data about the user who sent it. That is, every time a user sends a message, we will go to the database, check who this user is, take their current thread, and in that thread, send the message and launch the assistant. In this case, it will remember what the conversation is about, and each user who writes to our bot will have a separate chat with the bot and a history. Now let's try to slightly refine the current flow and add the saving of user dialogues. To do this, we will need to use some database where we will record data about the user and data about their thread. And at the moment he writes, we will check if such a user exists. If not, we will create them. And if they do exist, we will use their current OpenAI thread. I have prepared a new flow. Essentially, this part remains the same, but some steps are added here. Here we need to find the user, create a thread and create a user in Supabase. Let's go to Supabase. Here we create a new table and name it Telegram user. I usually specify the ID to be unique, and here is the user creation date, which is not particularly important to us. I also rename it so that the date comes first, as you may have many fields. Next, we will write the Telegram ID, and we also need to create and save the OpenAI thread. We write the OpenAI thread ID. It is best to adhere to naming conventions. If I use any third-party services, I usually write their name at the beginning, and then I write the essence itself with an underscore. If this is a link to some ID, then I write ID at the end. For the Telegram ID, we will choose int8, as it is always a number. For the pre-ID, we will choose text, as it is a string. We save, and then we can return here. We will copy this flow, transfer it, and make some changes here. We have ready modules, and we just need to add 2 modules as well as conditions. We go to the Supabase modules. First, we need to find the user. We select Get Many Rows, which means we will be searching. We connect this and enable it. We run it. Here we select the necessary credential that we already created. Here we select the table. We can see what has been created. We also need to choose the condition by which the record string will match. In this case, we will be recording the user ID. We write from here. Well, in our case, we need to write it. Thus, we will be looking for a record with a Telegram ID equal to this number. Next, there will be 2 conditions. When we have found the user and when we have not found them, we need to set a condition note. In order to achieve this, we can efficiently and swiftly test it again. It is also necessary to add the always output data setting. Otherwise, if you do not have at least one user, the scenario will end there, so this is very important. To start off, we should initially create a brand new user account, for example, in order to thoroughly test and evaluate our newly developed software module. User identification number. We chose the wrong ID. We need to select the Telegram ID, of course. We select. The record is found. We pin it, and then this data will be available to us. Next, we check whether the string exists in general. Select any string, mainly. This is the ID, and choose the exist condition to confirm that it exists. That is, if the user is not found, then this information will not be available, and we will have an expression that equals false here. Next, we make a branching. If we find the user, we will send them a message immediately. If we didn't find it, then we go to the thread, create a thread. Here, everything is already prepared for us. We simply create a thread. Next, we need to save the thread ID so that we can use it later. Again, we open the Supabase modules. And we do update.create because we are creating a user. This is cool because we are creating a user. Yes, in the Creator application, we carefully place it here, connect it, and securely select credentials.
We select the specific table and choose which relevant data we need to save. This is the Telegram ID, this is the OpenAI thread ID. We do not need to create the ID and date because they are created automatically. I forgot to mention this. Here are the default values when we created these fields. For the UID type field, there is a default value that generates random record IDs. The same applies to the date. Here it will simply use the current date of the present moment. It is better to also change to the current date, setting the zone. Here, specifically, we take the Telegram ID from the first module, and here in this process, we take the thread ID that we essentially create here, and we will replace it. In reference to the aforementioned point, specifically point JSON, we are now prepared. At this juncture, we proceed to implement the necessary update in accordance with the outlined plan. And then we essentially need to merge these two possible cases into one stream. If you do it this way, it won't work because it will be waiting for a response from each branch. For this, we need to use a specific tool to create an intersection. We delete here, we set merge, we connect here, first, second, second. The merge will be the usual one from the API. It will essentially show the latest data that was available before the merge module. Before the merge module, we will have a user record in both cases, meaning that if it is found here, the user's data will be present here. If the user data is not found, we will create it, maintaining the same structure so we can use it further. Since we are continuing to work with the data, meaning we are sending it to the thread that was recorded or created, we need to update the data here. We go in here. Yes, certainly, let's test merge. Indeed, as expected, the user will be found here. And everything will be fine here. We will gather the data. Next, we need to take the data for this module. Not to create a thread from the module, but from the merge module. And we take the OpenAI thread ID. We will copy it. Everything is fine here. We paste the same thing here. Oh right, do you see how? So JSON, I didn't notice. That's why it's better to change it right away. Let's return, here I will write, a point. This is a JSON point, here. At this stage, we are ready to duplicate the item or content. After copying, we proceed to paste it into the desired location. Finally, we make updates to ensure everything is current. That's it, now we have everything updated. We save the script and now we will try to write to the bot. Let's go to the bot. I have already written something before. Let's write, hello. Since we already have a record created, but the thread.id is not created, we will delete this record. Otherwise, we will have to create another condition when the user is found, for example, but the thread.id does not exist for some reason. But such a technical issue should not exist anymore. We will delete this record and send it. As you can see, a record has been created, and we will check that the script has started and gone through all the necessary steps. So, he answered us, and now we will check if he remembers what we talked about before. Yes, you see he remembers. In the first case we checked, the user was not found, and the path was empty. We went down this path, created a user, and then sent a message. We created a thread, created a user, and recorded all of this. In the second case, we already found the user and used the thread that was created earlier. And so, in a way that is quite significant, the assistant recollects in detail what happened before. That's all for now. Next, we will improve this scenario, add additional features to the assistant, and develop it into a full-fledged product so that more users can be added. and they can manage the prompts of the assistants themselves, and so on.
Thanks for watching. If you enjoyed this video, make sure to subscribe. Next week, I'll be posting a new video on how to create an interface for your web app using Bubble and Supabase, another crucial step toward building your own SaaS product. Don't miss it.